Welcome to my kcse revision channel, Teacher James Marita, Revolves Boys High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Our topic of today is calculus, that is differentiation. So we have a 10 marks question here and we want to revise. This is a question which normally never misses in an exam and especially in paper 2. The equation of a curve is given by y is equals to 3x squared minus 4x plus 1. So this is the function. This is a function of the curve y is equals to 3x squared minus 4x, then we have plus 1. Then we are supposed to find the gradient function of the curve and its value when x is equivalent to 2. At this point, you need to recall methods of differentiation, how to get the equation of the tangent, the equation of the normal, and how to get the gradient function. And of course, here you need also to recall the point of maximum and the point of minimum. Now, to get the gradient function of this curve, we have our curve which is equals to, the curve is equals to 3x squared minus 4x then plus 1. To get the gradient function of this curve, you need to differentiate the function. So if you differentiate this function, you have a dy all over dx, which is of course, in this case, this is our gradient function, which will be equivalent to differentiate this one now, you take 2 times 3, which is giving us 6, and then you reduce this to by 1, so you will have x raised to power 1, so we have that as x raised to power 1. Then here we have it is x raised to power 1. So 1 times 4 is giving us 4. Then if x is raised to 1 and if you reduce this x by 1, if you reduce this is 1 minus 1, of course we can have x raised to 0. And any number raised to 0 is normally equivalent to 1. So 1 times 4, we have this one as 4. 1 is a constant. The derivative of a constant is normally equivalent to 0. So this is our gradient function. The gradient function of this curve is dy dx, which is equals to be 6x minus 4. So this is our gradient function. Now what is the value when x is equivalent to 2? So we have our gradient function, then at x is equivalent to 2, at x is equals to 2, what is this gradient function? Then we have our dy, then we have dx, which will be equivalent to, we have now this one as 6, we have that one as 6, 10 times 2, because the value of x here is equivalent to 2, and of course here you subtract this one 4. So if you work out that, you will get that 6 times 2 is equivalent to, this one is 12, then you subtract 4, and our gradient in that case is equivalent to, we have our gradient which is equivalent to 8. So the gradient function of the curve is x, 6x minus 4, and when the value is, when x is equals to 2, the value of that gradient function will be equivalent to 8. Determine the equation of the tangent to the curve at the point, the equation of the tangent to the curve at the point 2, 5. So suppose this is our, if this is the curve we have, so we have a tangent. We can have a tangent here. So this is normally a tangent there. So the equation of this curve, the equation of this curve at the equation of the tangent, this tangent at this point, which is 2, 5. We have already the gradient of this curve. The gradient of the curve at this point here is equivalent to 8. So we can have that tangent like that, where we have the gradient is equivalent to 8. We have let another node point in form of x comma y. And then we have been given here the points which is 2 in this case, comma 5. So to get the equation of the covered this tangent, we have change in y, which is y minus 5. You divide it by change in x, which is x minus 2. That one will give us the gradient. So we have this as y minus 5. You divide it by change in x coordinates, which is in this case x minus 2. And this one will give us the gradient. And our gradient from part 1, which was equivalent to the 8. So you can put this one over 1. So we have as 1 times y minus 5, it is y minus 5, which will be equivalent to 8 times x. If we have this as 8x, we subtract 8 times 2, this one is giving us 16. So in the form of y is equals to mx plus y, our equation will be equivalent to the 8x minus 16, and in that case now, you add 5. So we are transferring this 5 from this side to this side. At this point here, it is a negative. When this crosses the equal signs now, it becomes our positive. So the equation of that curve will be equivalent to the 8x. Then we have here, we have minus 16 plus 5. You can use a number line or you can use a calculator. And this one will give us minus 11. That one is the equation of that, the equation of the tangent at that curve. So we have another question, part 2, where we are supposed to find the angle which the tangent, the angle which the tangent to the curves at the point 2,5 makes with the horizontal. So we need to get the curve, the angle here. So this one is very simple because already we have our gradient. So we have our gradient like that. Our gradient of the gradient of that, the curve is equivalent to V8. So to get the angle at which the tangent to the curve at the point 2,5, we have our gradient is equivalent to 5. Then the relationship here, you say that we have tan theta, where theta is the angle of the tangent, will be equivalent in this case to the gradient. This one will be equivalent to the gradient, and in that case, our gradient in that case is equivalent. Our gradient is equivalent to 8. So we find now tan theta here, our tan theta, which is equivalent to the 8. So to have the tan, we find the tan inverse on both sides, such that we have now theta will be equivalent to the tan inverse of 8, and this one will give as 82.8. So we have this one as 82.8 degrees. This is the angle which the tangent to the curve at the point 2,5 makes with the horizontal. Then we have the equation of the line through the points. The equation of the line through the points 2,5, which is perpendicular to the tangent, and that is perpendicular to the tangent, this one here. So what you need to understand, we have the gradient of a normal here, the gradient of the tangent in that case. We have that gradient. We have that gradient, call it gradient M1. So M1 is equals to V8. And since the lines here, it is now which is a perpendicular, we can have a perpendicular here. We have a perpendicular here. Then we have the equation of a perpendicular, and this the gradient of perpendicular lines. The product of their gradient is equivalent to -1. So if we have our gradient 1 is equals to P8, then our gradient 2 will be equivalent to, so we just say here that our gradient, the relationship we have gradient 1 of course, then we have gradient 2, this one is giving us -1. That is the relationship we have when the lines are perpendicular. The product of their gradient is normally equivalent to -1. Now that we have our gradient 1 here, which is equivalent to 8, so we substitute here that 8 times m2, that one will give us m2, this one is giving us 1. Then from here, our gradient 2 will be equivalent to -1 all over 8. Now, if that is what we have as the gradient 2, so we can have that line here where we have our gradient, which is -1 all over 8, of course. And then we have this point here, which is 2, 5. So we have this is point 2, in this case, 5. You let other unknown points in terms of x and y. So we have this is x, then we have y. So you can find now the equation of that line by saying that the gradient of a line is normally given by the change in x coordinate and the change in y coordinate. You divide by the change in the x coordinates. So in that case, we have change in y coordinate. So y coordinate, our y coordinate will be y minus 5. So we have y in this case minus 5. That is the change in the y coordinates. Then we have the change in x coordinates, which is giving us x minus 2. So we have this is x minus 2, and that one will give us the gradient. And our gradient in this case, we are talking of this gradient here, which is equals to -1. We have that one as -1 all over 8. So we can have cross multiplication here. 8 times y minus 5, we have as 8y minus 8 times 5 is giving us 40. This one will be equivalent to -1 times x, we have -x, -1 times -2, negative times a negative is a positive, so we have that one as 2. So we have here as 8, we have 8y is equals to p minus x, in this case, plus 2. Then now we are removing this -40 from here. It will close the equal signs where now it will change the sign from a negative to be a positive. So we plus this one here, plus 40 in that case. So we have as 8y is equals to p minus x in that case, then you plus 42. So you can leave the equation at that point because there is no condition given. But if you want to leave the equation in a form of y is equals to the mx plus c, then you can divide here by 8, you divide here by 8, then you divide there by 8. Then from here, our y is equals to the -1 all over 8x, then in that case plus 21 all over 4. This is the equation of the line through the point 2, 5, which is perpendicular to the tangent. Don't forget to subscribe, watch, and share. Thank you for watching.